Okay, we are live. Let's take off this extra screen, which is a recording screen. OBS Studio works very well, except for this part. Now, in today's machine learning journey, we're going to be moving forward with the Google Machine Learning Crash Course. Beforehand, we went over the all the areas that it goes over, and this is the pre-work. Now there are some prerequisites, but I meet most of them, at least in the past, and then if I can't remember, I'll just figure it out, which is algebra, linear algebra, trigonometry, statistics, calculus. I was really good in statistics in college, like very good, and all this other stuff. We know enough. This is the top-down approach. So let's move forward by being top down instead of learning all little things and finally doing something at the end, years later. Let's just learn what we need to learn and move forward. So the first thing we need to learn for this course is the pre-work, and that is the Introduction to Machine Learning Problem Framing. So you're going to follow along on my learning journey, whether you like it or not. It'll be me staring at a screen, clicking on some stuff, trying some stuff out, installing stuff, uninstalling stuff, and messing around. I'm on a really cheap Lenovo ThinkPad T560, old, $200, eBay, and it has Linux Ubuntu on it, if you haven't noticed. So, it's nothing for me to be worried about. You can see everything, and that's fine. Now, here we go. Introduction. Welcome to Introduction to Machine Learning Problem Framing. This course helps you frame machine learning problems. It will take an hour, supposedly. Define ML terms. Describe examples of products that use ML and general methods of ML problem solving used in each. Identify whether to solve a problem with ML. Compare and contrast machine learning to other programming methods. Apply hypothesis testing and scientific method to machine learning problems. Have conversations about machine learning problem solving methods. This course, define a problem and propose a solution. Construct your data set, transform data, train a model. That's the rest of ML. This course covers the beginning. Define a problem and propose a solution. This is course right for me. Yes, move forward. In basics terms, machine learning is the process of training a piece of software called a model to make useful predictions using a data set. This predictive model can then serve up predictions about previously unseen data. We use these predictions to take action in product. For example, the system predicts that a user will like a certain video, so the system recommends that a video to the user. Sorry, I'm not really speaking out loud to you specifically. I'm thinking out loud to myself, but I can think in my brain because that would be better for all of us, wouldn't it? Oh yeah, supervised and unsupervised learning. I know a bit about this before I even read that. Supervised means you have data available, and unsupervised means you don't have data available on that problem. So you have supervised means you have a data set, unsupervised means you don't have a data set. And there are particular things you do based on that. Now, if you have data, obviously that's better because it's, data. We're always looking for data, always trying to take data. Everybody's trying to gather data. There's a thing called big data. So, yeah. But what I really want to get into is reinforcement learning. But we have to go through this too. So, what is supervised learning? I feel like I skipped something. No, I didn't. Learning is a type of machine learning where the model is provided with labeled training data. Yeah, not just data, but data that's labeled. It's not just 1, 300, 700, D, 45. It doesn't make any sense to anybody, right? It tells you, hey, this is the leaf width for the leaf in an oak tree or something. They did this over like some kind of square acreage, and they measured the leaves and got different species, small oaks and big oaks. Just trying to be funny. Oh crap, they actually have a real botanist. For example, an amateur botanist determined to differentiate between the two species of, I'm not going to try to say that, genus. A completely made up plant. Great, so this is the data set. Cool, we have data. It looks like an Excel file. I thought this was supposed to be cool and fun. You're throwing Excel sheets at me? No, it's fine. That is a lot of it. That's the data science part of it. Leaf width and leaf length are the features, which is why the graph below labels both of these dimensions as X. There's a big leaf variety and a small leaf variety. A real life botanical data set would probably contain far more features, including descriptions of flowers, blooming times, arrangements, but still only have one label. Features are measurements or descriptions. The label is essentially the answer. For example, the goal of the data set is to help other botanists answer the question, which species is this plant? This data set consists of only 4 examples. A real-life data set would likely contain vastly more examples. So, as you can see here, I think this is simply showing that there are leaves bigger and wider. Well, longer and wider. The big leaf has, well, a big leaf. And it's more width and more length. So you can see here, the small leaf is 5.1 and below 3 inches in width. But the big leaf is over 3 inches in width and over 5.1 or 5.5 in length. When you pop it out, you can see the trend. In supervised machine learning, you feed the features and their corresponding labels into an algorithm. Yes, the algorithm. Guess what? We're going to make the algorithm. Or take an algorithm and manipulate it. And we train the data set. Not the data set, we train the AI, or the machine. Gradually determines the relationship between features and their corresponding labels. This relationship is called a model. Excuse me. Sorry. It's been a long day. Oftentimes, in machine learning, the model is very complex. However, suppose that this model can be represented in a line that separates big leaf from a small leaf. Also, as a note, when I'm doing these videos, it's late at night. Right now, it isn't that late. I've made a time schedule for my whole life so I can get everything I want to done in it. And for right now, machine learning, this video and such, is happening between 8 and 10, supposedly. That's what I'm trying to do. Those are my allotted times. When those time hits, everybody knows what I'm doing. Gonna be on this computer, making videos, learning machine learning, and making projects. That's it. And when that time's over, I'm done. You should try something like that too. Make specific times for what you want to do when you have a goal for something. It helps out a lot because other times you'll have something come up and then poof, that time's gone. And then another day comes and something else gets in the way. There's always something in the way. And the next thing you know, a month goes by and you haven't learned anything. You haven't done anything, and then you're angry at yourself. learn from me. I've already done that. Not doing it anymore. Make a schedule. And then follow it. Alright, I read that. I'm going down. Here's the pattern, which is kind of like a trend line. This is the labeled data for the big leaf and for the small leaf. As you can see here, got something going on. Now that model exists, you can use that model to classify new plants that you find in the jungle. So now you find a different kind of genus, or a totally different plant, and you measure the leaves, and you get another pattern. So, to tie it all together, supervised machine learning finds patterns between data and labels that can be expressed mathematically as functions. Given an input feature, you are telling the system what the expected output label is, thus you are supervising the training. The machine learning system will learn patterns on this labeled data. In the future, the machine learning system will use these patterns to make predictions on data that it did not see during training. Apparently it's being used to detect skin cancer in images. It showed you, I showed you what skin cancer looked like. And on women or men, ages, a 5-year age range here, 40 to 45, then another 5-year range, 60 to 65. Found the trend line, there it is. Measurements for all the little dots, color of the dots, etc. And then made a very similar pattern. And poof, supervised learning for skin cancer. These guys are geniuses. Thank you, Stanford. Isn't that from where Andrew NG is from? Machine learning system found signals that indicate each disease from this training set. Yeah. Now we go into unsupervised learning. In unsupervised learning, the goal is to identify meaningful patterns in data. So we got all these dots. It looks like there's a trend line going this way. What does it all mean, Basil? To accomplish, the machine must learn from an unlabeled data set. In other words, the model has no hints how to categorize each piece of data and must infer its own rules for doing so. Sorry. It's extra cool. In the following graph, all the examples are the same shape because we don't have the labels to differentiate between examples of one type or another, like big leaf and small leaf. So fitting a line to unlabeled points isn't helpful, like what I just did. We still end up with examples of the same shape on both sides. Clearly, we'll have to try a different approach. Clusters, yes. Here we have two clusters, but they're arbitrary. What do they represent? Sometimes the model finds patterns in data that you don't want to learn, such as stereotypes or bias. They aren't useful, so what do? However, when new data arrives, we can categorize it pretty easily, assuming it fits into a known cluster. So we made an arbitrary area, and then new data comes in. Hey, why is this over here, and why is that over there? What if your photo clustering model has never seen a pangolin before? A pangolin? That's that armadillo-like thing in China. Will the system cluster a new photo of armadillos or maybe hedgehogs? Not a hedgehog. Definitely of the armadillo type. This course will talk more about the difficulties of unlabeled data versus clustering later on. But I want to learn now. Reinforcement learning. Here we are. Why is this? I guess I'll learn this later, but why is reinforcement learning always third place? Why is it not first above supervised and unsupervised? I think it's much cooler. An additional branch of machine learning is reinforcement learning. Reinforcement learning differs from the other types of machine learning. In RL, you don't collect examples with labels. Imagine you want to teach a machine to play a very basic video game and never lose. You set up the model, often called an agent, with the game, and you tell the model not to get a game over screen. During the training, the agent receives a reward when it performs its task, which is called a reward function. With reinforcement learning, the agent can learn very quickly how to outperform humans, because it quickly learns it doesn't like failing. Guess what? Guess who else learns from reinforcement learning? We do. We get praise when we do things right when we're young. Maybe it's a smile. Maybe it's candy. Maybe it's extra time playing that video game when you were a kid. But it's all reinforcement. And it works very well. Here we go. The lack of data requirement makes RL a tempting approach. However, designing a good reward function is difficult. Yeah, you can't reward a kid with broccoli for eating his vegetables. He just ate those. You need to have the right thing. Reinforcement learning models are less stable and predictable than supervised approaches. Of course. Additionally, you need to provide a way for the agent to interact with the game. To produce data, which means either building a physical agent that can interact with the real world or a virtual agent. In the virtual world, either of which is a big challenge. See this blog post by Alex Erpan for an overview of the types of problems currently being faced. Reinforcement learning is an active field, but if you focus on this course, we will focus on supervised solutions because they're a better known problem, more stable, and result in a simpler system. And it's also easier to teach because you can just throw a data set at me and you know the answer already. But with unsupervised or reinforcement learning, one, it's harder, and two, you don't really know what the right answer is, so you can't really test me. Sure. There are several subclasses of ML problems based on what the prediction tasks look like. Common classification problem. Pick one of the N labels. Cat, dog. Regression. Predict numerical values. Click-through rate. Clustering. Group. Similar examples. Most relevant documents. Association. Infer likely associating patterns in data. Structure output. Create complex output. Natural language. Parse trees. Ranking. Identify positions on scale or status. Check your understanding. Uh-oh. Did I learn anything in the last couple of minutes? Let's see. Which ML problem is an example of unsupervised learning? Click on answer to expand a selection and check your response. Unsupervised. Clustering. I just got lucky in that one. Okay, contrasting cases. As you walk through each example, note the types of data used and how that data informed the product design and iterations. Think about how the examples compare and contrast from each other. Click on each product name button to see more info below. YouTube watch next. Oh my god. Is there more things to watch inside of more things to watch? Such short responses. Smart reply is an example of an ML that utilizes natural language understanding. Generation things. Respond to an email. That's useful. YouTube watch next. That feature. What to watch next. It's a neural network, deep mind thing. Basically a recommendation engine for video. See, that's YouTube, it's owned by Google, so there you go. Cucumbers. Why does that sound familiar? See how cucumber farmer uses machine learning to sort cucumbers by size, shape, color, and attributes. Guess there are different colors in Japan. Huh. A cucumber farmer. For real? Amazing. Think about the similarities and differences between each of the above cases. Let's take a short break.